Hopefully this is not disturbing. Okay, so if you remember, we talked about functions. So if I want to remind you a little bit of what we learned before, I told you that a function is, you can imagine a function as an operator or as a machine that takes you one or more inputs and gives you one or more outputs. Okay, for example, if I want to go back here, this is the only one that you need to know at the level of the book. You have a function which is an operator. It takes only one input, do some process on that input, and gives you an output, one single output. Even though, if you remember, I talked about abstract notions of functions, that function is just a rule that assigns some uh, elements from one set to elements from another set in a way that, first of all, every element on this first set should be assigned to one of these elements, and this assignment should be unique. So I am not allowed to assign A, for example, to lambda simultaneously to alpha. This is not possible. One arrow and exactly one arrow should go out from each one of these elements from the left hand side. But this is, I just wanted to know as extra piece of information about the functions. Then in mathematics especially, we work with functions that the inputs are somehow numbers, the outputs are also somehow numbers. So you put in a number, the function operates something, process that number, and gives you a number back. So the functions that are in the book are the functions of this form. You give one number to your function processes it and gives a number back to you. The number that you put in is commonly denoted by x, and if the function is f and the final processed product is this, I will call it f of x. This is called f of x, means that the output of machine f after the machine applies on this input x. But I just want you to understand a little bit broader the concept of function, and I told you that there is no necessity that your machine, by the way, one important thing was here we talked about these kind of functions with more than one rule. So you can imagine them. Again, you put one input here, you again get one output, but internally, this machine has two parts, for example, two subdivisions here. When you send an x here, this tells this function applies like this, acts like this. It tells to itself that if the input that you are sending in is greater than or equal to 3, I will send this input, for example, to this part of my internal structure. There, the number is multiplied by 2 and 5 is added to it. Then it will be my output. And if I see that this number is smaller than 3, I will send it to this part of the internal structure. And then the process that is done on that number is that number is one is subtracted from that number, then I get the output. Yes, so that is one possibility. So even though I am sending one input and getting one number as output, but the machine has internal structure in itself. Here, this machine has two internal structures. It can have more internal structures. Okay, but then I told you that this is not a necessity at all. You can have a machine, for example, with one internal structure, but you can send more inputs to it. And then this function starts processing on both of these numbers simultaneously and give you an output. For example, then I give you an example of this kind of machine that you can imagine. F of x and y is x squared plus 2y. By the way, these are not artificial ones. For example, if I have a rectangle whose length is x and its width is y, I can imagine this function a of x and y becomes xy. Yes, this function is actually a very famous function. Yes, this is the area function. The area function for this takes two numbers from you. One of them is the length, the other one is the width, and this function multiplies them and gives one number back to you. So if you want to imagine this, the area function can be imagined like this. I send x here, meaning the length. I send a y here, meaning the width. And this area machine, what does this machine do? It multiplies them and give this xy back to you. So what you get here is actually a acting on these two numbers that you are sending in. So do not imagine that these things should be complicated. No, they are not complicated at all. For example, this very simple example is a function. This area function is a function that takes two numbers in and gives you one number back. The numbers that this machine is taking in are the length and the width of this rectangle, and the number that this machine gives you out is what is the area of that rectangle. So you see, don't think that these are very complicated thing. Actually, this is a very, very simple thing, calculating the area of a rectangle. So you can see calculating the area of a rectangle as a function with two inputs and one output. Yes? You can also, for example, make artificial examples of functions. So what I'm trying to say, don't think that you need to find something in the universe that matches with your function. No, function is an abstract entity, is an abstract mathematical concept. So for example, here, if you remember, I imagine just a very simple machine that takes 4 inputs from you, do something on that 4 inputs, and give you something back. In this case, this function takes 4 inputs from you, and what does this function do for you is just doesn't care about these 3 at all, only emphasizes on the third one. So it takes 4 inputs from you, eliminate the first one, the second one, and the fourth one, and just give you the third one back. So these are the ideas that you can think. So hopefully I want you to understand how generic is the notion of a function. So for example, if I want to give you another type of example, for example, assume that you are interested in both the area and circumference of a rectangle. So simultaneously, for some reason, you need to know both of them. Okay, so then what you can imagine, for example, let me see. Yeah, let me just give you another example. So I just want to make sure that you understand how generic is the notion of a function. So assume that you have a machine here. Imagine that you give the length and the width of a rectangle to your machine, but for some reason you are interested both in the area and the circumference of that rectangle. Okay, and then you get something out of it. For example, how many inputs you put in, 2, how many outputs you are supposed to get in this problem, 2. One would be the area, one would be the circumference. Okay, so this I can call it function. For example, let me just use the capital G letter. So what does it mean? It means that this function takes two inputs from me and gives me two outputs. So one output is, for example, the area, and the other output is the circumference. Yes. So you see, this is also a formula that takes two inputs, gives you two outputs. Yes. The first one, for example, we agree that the first number that this machine gives out is the area. The second number that this machine gives out is the circumference. So that is also something possible. Okay. For example, if I ask you what is G acting on 2 and 1, what is the answer? The answer is simply two numbers. The first number is calculated by the product of these two, which becomes 2. For the second number, I add the inputs and then multiply it by 2. So I add the inputs, it becomes 3, and then multiply it by 2, it becomes 6. So make it right. But at the level of functions, you don't need to assign a meaning to these values. So when I see this as a mathematician, when I see this function, I realize that this function takes two input in, do some process on these two numbers, and gives me two numbers back. One of them happens to be the product of these inputs. The other one is the sum of these two inputs multiplied by 2.
Babak,
So, yes?
Like the G parentheses 2 and 1, they really look
Yes.
like coordinates. How do you tell them apart?
Yeah, that is a very good question, but you shouldn't. This is something happening in mathematics. You are right. This one, you can also consider this as a point in the coordinate system, but this is not exactly the case. When I have a function, in front of my function, I have a bunch of numbers. I mean the inputs. I can call it the first input, the second input. If I have 3 of them, I can call them the first input, the second input, and the third input. You can also think about this as coordinates, but I don't want to make the problem harder and harder, okay? So just think about this in this way. When you see a function, in front of a function, you have 2 pair of brackets. In the pair of brackets, you can either have one number, which is the lesson in the book. The lesson in the book only talks about a function f with one single number inside and with one single number outside. The single number inside, usually in mathematics, is called x. The single number outside, usually it is called y. This is for the case of one variable and one output, one input, one output.
Will the
But
book mix the coordinates and functions?
no, we don't mix them. I'm just talking about functions for the time being, okay?
I have a
I will
question.
talk about the graph of the functions a little bit later.
I have a question.
Yes?
How can you tell apart the area and the circumference in the equation?
No, you need to have an agreement, okay? So you
Got
need
it.
to, so if you want to assign a meaning to what is calculated by a particular function, more than one variable, yes, you need to tell to tell yourself, because when I put a number here, if I want to give meaning to x and y, I should say that I agree among ourselves that the first number represents the length, and the second number represents the width. And then I need to also mention that the first output, we agree on it, that should be the area, and the second number should be the circumference. If I don't tell anything to you, you need to look at this function as a very abstract notion. You need to think in this way. This function takes two inputs from me, x and y, in order. X is the first one, y is the second one, and gives back these numbers to me. This product as the first output, and this sum multiplied by 2 as the second output. That is the only thing that you can realize by just looking at this given function. I am just giving an idea to understand that even though this is quite complicated function if you want to compare it with the level of your lesson, but it is not something that is very complicated. I give you two numbers, then I ask you calculate the area and circumference. Usually I talk it in words. I give you the width and the length, and I ask you to calculate the area and circumference. I just want you to understand that when I am talking about this simple problem, actually I am talking about functions in some indirect way, that getting you two numbers, then that takes two numbers from you, gives back two numbers to you. Okay? Is that understandable or not?
Yeah, I understand now.
Okay. So for example, don't look at here. So let me just clean this one. For example, here, if I ask you what is in the same function, what is g of 1 and 2, what is this? Can you just give me how many numbers I should expect you to give me for this function?
2.
2. So what is the first one?
2.
What is the second one?
4.
The second one is not 4.
Is 6.
It's 6 again.
Yeah.
Okay. So this is a coincidence. So this means that this function is not sensitive if I interchange the first input and output. It gives me the same outputs back. But this is not generic. Might be, so let me just write examples one after the other. You will learn finally. This is not very hard. So for example, I can assume a function h acting on two numbers, but gives me back three numbers. I can say it gives me x plus y, it gives me x minus y, and it gives me x divided by y. Okay? Is that understandable? So if I ask you, do you understand what is written in front of you? I just want you to have this feeling that this is not something mysterious now. If you see this in front of yourself, you realize that h is a function, and then how many inputs it needs to call the first one x. You can call it t, you can call it whatever you like, it doesn't matter. The first number, I call it x. The second number, I call it y. But how many outputs do I expect after this function has processed the inputs?
3.
3. The first one, for some reason someone is interested in, forget about this, think abstractly. The first number is the sum of these two entries, the inputs. The second one is the difference of the first minus the second, and the last one is x over y. So here, if I ask you what is h of 2 and 3, what is the answer? Can you tell me? How many numbers are you expecting to get?
3.
3. So what is the first number that you get?
5.
5.
5. Exactly. What is the second number that you get?
-1.
Exactly. And what is the last number?
2/3.
Over 3.
2/3. Very good. So you see, as simple as that. That's the notion of function. And let me see that, is it sensitive if I change the numbers? Now I apply h to 3 and 2. Let us see if the result is exactly as before. What is the first number that you get from this function for these inputs?
Still 5.
5.
It's still 5. What is the second one?
1.
1. And what is the last one?
3/2.
3/2. Everybody understands that, yes?
Yes.
Because this
Yes.
tells you that the inputs, this is very important to keep order in mind. This is called, I called it x. It doesn't matter the name. The important thing is that this is the first. This first is important. The first input. Y is something that I use for the second input. This second is important. This tells you that this function applies on 2 inputs, gives back to you 3 outputs in this way. This function takes the first input, takes the second input, add them, and give them back as the first output. The second one, it takes the first one, the second one, subtract them, and gives you back as the second output. And then this means that this takes the first one, takes the second one, divide them, and gives you as the third output. So this is very clear that now, do you think that these results are the same? Do you think at H acting on 2 and 3 is equal to H acting on 3 and 2? Yes or no?
No.
No. Even though they have something in common, but they are not 100% equal. So I would say that here H of 2, 3 is not equal to H of 3, 2. But here in the previous example, G of 2, 1 was exactly equal to G of 1 and 2. Okay, so you see this is a function that is a very abstract function. We don't know what is the name of this function. Might be we can cook up some scenario that this function becomes useful in that scenario. But at the level of functions, we don't actually care. What we care is that we have a rule assigns a triple to an ordered pair. This is the function. This is the role of this function. Okay, so now let us go back. So these things, so whenever I have an example which is not of this kind, this is not at the level. The book only considers about these 2 types of examples. One type of examples is this, and one type of example are similar to this. So either we have we have always a single input and a single output, and either the machine has one internal structure, is just without any other ones, or the machine that you are thinking about have more than one internal structure. So these are the functions that you need to you expect to see in the book. This is called a function with one rule. This is a function with multiple rules. Here I have one rule, another rule. So these are the functions that you need to know very good, at least. But hopefully I could teach you something about a function in general. So it doesn't matter. You don't need to limit yourself to one variable as an input and one variable as the output. Okay. Now let us, without any questions, without any teaching, let me ask you these questions. Can you understand these? I am completely sure if you understand what's going on, you can understand them. So example. So let me start with very simple examples. This is exactly at the level of the book, so you have to know whatever I am saying from now on. So let f of x be equals to x divided by, let me avoid this division for the time being, x times x plus 1 to power 2. Okay, determine f of 1, f of minus 2, f of a, and f of a minus 1. Let me write b minus 1. I just want to play around with this, that the names are not that important when you're dealing with functions. So this is one type of example that you really need to know. It's very, very simple. But I want you to not memorize that. I want you to understand. And understand it by this analogy of thinking of a function as a machine that here gets one input from you and do some process on it and gives it this number back to you. If you want to visualize that, this would be something like this. You send an X to your machine. This machine is called F. And what you get out is x plus 1 to the power of 2 multiplied by x. This is what you get when you send x to this machine. So what does the function do for you? It takes your input, add 1 to it, square the result, and then multiply it back to the original number. And when everything is finalized, it gives you this number back. This is the role of this function. You need to remember this idea in the back of your head if you want to understand the functions in a very nice way. If you now I can go to the solution, because now if you think in that way, it is super simple to solve this problem. Okay, tell me, what is f of 1? But how you need to write in the exam to show me that you understand this. When you say f of 1, it means that now you are sending 1 inside your function. But your function always does the same thing. Yes, so f of 1 becomes the function takes 1 from you, add 1 to it, square it, and then multiply it by the number that you gave in. So, and then you can calculate it. So it is 1 times 1 plus 1 is 2, 2 to power 2. So it is 1 times 4. The answer that you get out is 4. Is there any one of you doesn't understand this calculation? Not just calculation, because the calculation is simple. I can tell you that, okay, remove x and put 1 inside. I don't want to kill the mathematics like this. I want you to have a good understanding of what is the meaning of a function. Otherwise, I could tell you that, okay, calculate this expression. If I don't want to use the notion of derivative, I can give you and I can tell you calculate this for x equal to 1. Even though the answer would be 4, I intentionally write it in terms of functions because I want you to understand the notion of functions. Okay. Is this calculation clear for everyone?
Yes, this is very good. Thank you.
Okay. Okay. So let us go to F. So let us repeat these ideas over and over so that we actually start respecting them. Now, after this process is finished, I decide to send -2 in, even though I am changing my input, but the function is the same machine. It will always do the same operation. Okay, so what was the role of f? The role of f is that it takes an input from you, add 1 to it, and then square it, and then multiply it by your input, and then give the result back to you. So what does it mean if I want to calculate f of -2? The function takes -2 from me, add 1 to it, square it, and then multiply it by -2. And then the rest of it is just simple calculation. So I have -2. -2 plus 1 is -2 to power 2. So it becomes -2 times -1 to power 2 is 1. So the answer is just simply -2. You see, the calculations are simple. So the calculation is not my emphasis. My emphasis is understanding the concept. Okay. Now I change my mind and I calculate f of a. So f of a, now I am sending a inside, even though I have changed my input, but my function is remaining the same. That's the same machine. So it will take a from me, add 1 to it, square it, multiply it by the input, and give it back to me. So that's the end of the problem. You can stop here. Of course, if you want, you can simplify and expand this, but that is not very important for the time being. If I want you to expand this, I would explicitly mention that you have to simplify the output. But if I don't, you can just leave it like this. Okay, now I am asking you what is f of b minus 1. So what I do the same thing. The function takes the input from me, but this time the input has another name. The name is b minus 1. It takes the input from me, add 1 to it, squares the result, and then multiply it to the input. But you need to respect something. If you write something like this, that is not 100% correct, because the input is the whole expression. So I have to put a pair of brackets here. Here, I usually prefer to simplify, especially a very simple case, because nobody writes -1 + 1, because we know that this is canceled. So it is better to write b minus 1 as before. Oh, sorry, b minus 1, and then I have b squared. Then I can stop. If you want, of course, let me just do this one. I can multiply it inside. So it becomes b to the 3 minus b squared. But these are minor things for the time being. Not that is not important, because now we are talking about functions. I don't pay that much attention to simplification here. What I want you to understand is this part of the calculation. Okay, so this is one very simple type of problems. Hopefully you remember this idea forever. One thing that I want to mention again is the name of the letter that you choose for naming your input. Okay, I have made a mistake here. No, so let me edit this, because this is not part 1, this is part 2. Okay. Everything is right now, yes, except for that. Okay, so what I want you to understand, let me tell you something. When you write f of x is equal to x squared, if someone asks you, what is the role of this function? You say that, okay, I give input x, it gives me x squared back. What I want you to understand is just x is a way that I express the input. If I write something like this, do you think this is a new function? Do you think that this is defining a new function, yes or no?
No.
This is exactly the same function, because if I ask you what is this function, you can say this is a squaring function. For example, if you want to write it in words. If I ask you what is this function, the name is again a squaring function. I don't know, but here people used x to express themselves that this is a squaring function. Here people have chosen to use letter A to express that one. Might be if we are leaving, I don't know, very long back, people doesn't know about A or B, I don't know, but might be they write something like this. A star, and then they write a star to the 2. So that's also a squaring function. So what I want you to understand, there is nothing specific about the letter X that we are choosing, even though most of the time we use the letter X for the input, but we can equivalently use any other letters or even symbols to denote, to express what we mean by this function. By looking at this, at this, at this, I will get the same conclusion for the role of my function. By looking at this, I understand f is a squaring function. By looking at this, I will get exactly the same information. F is a squaring function. By looking at this, I will also get the same information. F is a squaring function. So that's very important to realize what is the meaning of an input. So X, alpha, A, star are just symbols that we use to denote the input. Okay, so that's also one thing that I want you to know about. Okay, let me go through some more interesting problems now. Example. So let me consider 2 functions. So I keep it simple for the time being. Let f of x be 2x plus 5 and g of x be 3 minus 2x. Determine f of 5 plus g of minus 2 and 3f of 0 minus 2g of 10. We want to calculate these things. So I don't think this is hard at all. So you see, I have two different machines here. One of them is the F machine here. Yeah, it's better, I think, to draw it like this. But it doesn't work with this hoop. I think so, yes. So I have an opening here, and I have also an opening here. So here, F, what is the meaning of F? F takes an input, which call it X, and then I will get something out of it, which is 2x plus 5. Yes, and this is the function F. Okay, and now, if I want to consider the same thing for function G, I can assume it in this way. And then here I am sending X into machine G, and what I get out is 3 minus 2x. Okay, first of all, I want to test your understanding. By looking into these diagrams, do you think that this X and this X has to be the same?
Yes,
Yes or no?
I think so.
So for example, these two X's doesn't have to be the same. The reason is that I told you that X is just one way to express the input. Okay, so by looking, you need to read this whole diagram as a whole. You cannot read them separately. So you need to read this diagram in this way. I say I send an input in, I will get 2 times that X plus 5 out. And if I send an X here to this machine, I will get 3 minus 2x times. So it might happen that you decide to send 2 to this machine, simultaneously send 3 to this machine. Is it possible or not? Because if you say that they have to be the same, it means that whenever I send 2 to this machine, I have to send 2 to this machine as well. But hopefully you understand this is not the case, yes? You might have two independent machines, which they are. You can send one input to this, say 2, but simultaneously you decide to send another number different from 2 here, for example, 3. Yes? But you get one output for this machine processing on number 3, and you get an output here for machine F processing on 2. So this is why, for example, you see here, I have F of 5, but I don't have G of 5. I have G of another number. So this means that for F machine, I am providing 5 as the input. For the G machine, I am providing the minus 2 as the output, but for some reason, I get the output for this one, get the output for this one, and then add them together. Is that understandable?
Yeah.
Okay, so that is what I want you to understand. So if I ask you, how should I do that? So let me write the question mark. F of 5 plus G of minus 2 is my question mark. This question mark is the sum of the outputs of machine F and machine G. Machine F for input 5, machine G for input minus 2. Okay, so what should I do? First, I calculate F of 5. How should I calculate? I refer to my function F. So what is F of 5? It means that you need to interpret F takes input X from you, multiply it by 2, and add 5 to it, and gives back the number. So this gives me 2 times 5 plus 5. And the answer is 10 plus 5, and that is 15. And then if I ask you what is g of minus 2, you say that now you are interested in the output coming from machine G when the input is minus 2. So what should I do? I need to go to function G and then replace the representative for the input with this input minus 2. So the answer would be 3 minus 2 times another minus 2 because of my input. And then the answer is 3 plus 4, which is 7. So therefore, what is the question mark? Therefore, the question mark that I am looking for is the sum of this output and this output. One of them is 15, the other one is 7, so I add them. So the answer becomes 22. Yes, is this understandable?
Yes, it is, Babak.
Yes, okay. So I just want to wait 1 minute for you to do the next one yourself. This one, or 2 minutes, that's very simple. So please do this one and give me the answer, the final answer. Okay, did you get the answer?
Yes, it's 49.
Yeah, 49. How many of you actually did it? So hopefully more, I cannot see you, but hopefully most of you were able to do this correctly. Okay, so I would do it in some steps, yes. So for example, my question mark in this problem now is 3f of 0 minus 2g of 10. This is what I want you to ask. So I don't know, now that you have learned it in a proper way, hopefully you understand that you are not allowed to take this 2 and multiply it here in 10. Yes, because g of 10 is one single entity. So when this is, let me emphasize again from my experience, when I say f of x as a whole is one single entity. It is not f multiplied by x or whatever you can imagine. When you say f of x, this whole symbols you see, including the function's name, including a pair of brackets, including x, the whole package is one single number. So you cannot take this 2 and multiply it here in 10, because this 10 is not your number. The whole package of g of 10 is one entity. You need to find this, that is one single number. After it has been found, then you are allowed to multiply it by 2. So make sure that you are not confused. If you are, please let me know, and I will try to find a way to explain it better. Okay, so here I have f of x. Let me write everything patiently. F of x is 2x plus 5. The first thing that I want to do, I want to see how this function applies on this new input 0. You need to interpret it. You need to read it in this way. You say to yourself that this function takes an input x from me. Let us see what does this do for it. It takes that input, multiplied by 2, and then add 5 to it. Now I am sending 0 in. This function only knows how to do this operation. So it will do the same thing here. It multiplies my input by 2 and then add 5 to it and then gives it back to me. But of course, this answer is just 5. Let us repeat. The function g of x only does this one, 3 minus 2x. So you need to interpret it. G is a function. I gives it an input x. It multiplies it by 2, and then when the result is found, it subtracts it from 3. Now I am sending a 10 in, but the function knows only this job. So the function will multiply my input, which is 10 by 2, and then when it gets the answer, it subtracts it from 3. It seems that I am replacing x with 10, as simple as that. So this becomes 3 minus 20, so this is minus 17. And now my question mark is 3 times f of 0 minus 2 times g of 10. And then instead of f of 0, I can put 5. Instead of g of 10, I can put minus 17. So if I want to write them in a row, it becomes 3 times 5 minus 2 times minus 17. So the answer is 15 plus 34. The answer becomes 49, as you said. So that's also possible. But there is also another operation which is very, very important in functions, even though the book hasn't named it explicitly, but this is correct as well. Okay, so that is the composition of the composition of functions. This word you need to know, the composition of functions. Okay. But before mentioning anything, let me go back and write these functions again. So you remember 2x plus 5 was my function f, 3 minus 2x is my function g. So let me write it here. So f of x is 2x plus 5 and g of x is 3 minus 2x. Let me ask you, what is your opinion about this? The composition of two functions means doing one function after the other one, something like this. So can you tell me what is f first of g of 0? Do you understand what is going on here? If you see this symbol, how do you interpret that?
Does it mean to do first g of 0 and then use that as an input for f of, well, g of 0?
Exactly. Very good. Very good. So this means that, you see, if you see this symbol, if you want to start from here, when you see f of x, it means that what you see here is the input of your function. If I ask you what is the input of f, you would say that this is the input of my f. But if I ask you what this is, you would say this is the output of g for the input 0. So you see, I am applying f after g. So if you want to imagine it, it is something like this. I have two machines, one after the other. I am composing them. So let me draw a diagram for you. Okay, so let me make this an opening here. Yes, so here, which one is acting first, f or g? Of course, f is coming on the left. Usually we write mathematics from left to right, but which one do you think is applying first?
G of O.
G is applying first. So because G should apply on 0, gives you an output, and F should act on the new output. So it means that if I want to read the diagrams from left to right, what I am doing, I am sending 0 to the machine, which is called G. It gives me G0 out. And then G0, I will send it to this function f. It will give me f of g of 0. Is that understandable?
Yes.
Okay, good. So it means that if you want to calculate this, which is my goal, you have this diagram. You see the order is a little bit distracting. Here, when you want to write it, you write it from left, f coming first. This is called f after g. emphasizing it's a good way of memorizing, which is doing first F after G, if you want to write it, or you can write F O G. Yeah, I don't want to talk about this symbol because this is not in the book, but you can read it F after G. F after G becomes everything becomes clear. It means that G should apply first, F after G. If you want to see the diagram should be interpreted in this way. This is the diagram for this. Okay, okay, but if I want to do it, it is very simple. So it means that I need to be patient. I need to keep F as it is first. I need to calculate G of 0. Okay, so what is G of 0? G of 0 is 3 minus 2 times 0. Is that understandable? But 3 to this one has a better name, it is 3. So this means that this is f of 3. If I ask you what is f of 3, you need to go to your function, replace x with 3. So then it becomes 2 times 3 plus 5. So the answer becomes 6 plus 5. So the answer is 11. Please let me know if you don't understand. This is called composition of functions, f after g. Is that clear?
Yes.
Okay, now if I want to draw the same diagram, but let me ask you what is your opinion about this. I want to change my color. Instead of sending 0 to function g, let me send just x to function g. Okay, what do you get here? Let me, instead of 0, I put x. What do I get out? What should I write here on top? On this arrow?
X.
If I send x to machine g, what do I get here? Everyone?
You get G of X.
You can get g of x, but what is g of x? Is 3 minus 2x. And then I send this here, what I get? Okay, let me write it here for you. Might be this is a little bit hard. So what I'm saying is that if I ask you to do this, how do you do this? You know that the first function is g of x. When g applies on x, it gives you what? It gives you 3 minus 2x, and then you have f. Okay, so what's happening? Instead of this gx, I put this expression. But what should I write here? Can you tell me what should I write here? You need to interpret it again. What is the role of the function? The function takes an input called x from you, multiply that by 2, and then add 5 to it. But now the input is a little bit strange. The input is written in this way, but f only knows how to do one single job. The job is to multiply the input by 2 and add 5 to it. So it will multiply the input, which in this case is this, by 2, and then add 5 to it. I want to wait for you that if you understand this step. Everyone, is there any question?
No.
Okay, so then it is very simple. You just multiply 2 inside, it becomes 6 minus 4x, and then you have plus 5. If you simplify, it becomes 11 minus 4x. Okay, so this is the composition of two functions. We can talk a little bit, make it a little bit harder. For example, let me give you 3 functions. F of x, say 2 plus x. Let me give you another function g of x called with the rule of x minus 3, and then let me write another function h of x equal to say 2x minus 1. Okay, now can you give me what is the answer? I want to wait for you a little bit. F of g of h of 0. This is, so you can start calculating. Let me replace them. G of f of h of 0. What is this one? And then what is this one now? F of h of f of 2. Okay, I want to wait for you to see that. If you can calculate these things, it means that you really understand what is going on regarding functions. I just want to pause the video a little bit and then see how you are doing it. Okay, could you solve the problem?
Yes.
Okay, so I don't think it is hard. So let me start doing them one by one. So number one, so can you tell me what is the answer that you get for the first question mark?
-2.
Okay, let us check. So you are saying -2. Let us check how is that. So which one is coming? If I want to read it, I read it f after g after h, acting on 0. So, but I need to start from the first one because f is after g, g is after h. So what is applying first is h, then g after h, then f after g and h. Okay, so if I want to answer this, I would write f of g of h of 0. The first thing that I need to calculate is h of 0. So it means that when I want to calculate h of 0, I go exactly here, and then I will calculate h of 0. But what is h of 0? What is that? You need to replace x with 0 because your input is 0. So if you put this, it becomes 2 times 0 minus 1. The answer is simply -1. And you take this -1 and put it here instead of h of 0. And then you have to copy paste everything left. Okay, so it becomes f of g of -1. You see, I progressed one step. H is gone. H of 0 is being calculated to be -1. But then here I have to calculate g of -1. This g, it means that I go to this machine, I give -1 as the input. So the function will take -1 from me and subtracts 3 from it. So it becomes -4. And this -4 is what we need to replace for this. So it becomes f of -4. Yes? And then what happens? I need to take this -4 to my function f. And then what does this function do for me? It adds 2 to the input. The input is -4, so it adds 2 to it. So as you said exactly, it's -2. So the answer is -2. Okay? So this is the answer. Here, I have replaced, here I kept this the same, but I replaced f and g. So let us see what is the answer. What is the answer to this part? Anyone?
Wait, the second question?
Yes?
I got it to -4.
-4. Let us check that. And I intentionally gave the same numbers and functions because I want to show that in general, if you start interchanging these functions, there is no guarantee that you get the same answer. Do you remember the word commutative? So this operation, composition of functions in general, is not commutative. I am not allowed to interchange them blindly. Okay, there is no guarantee for that. So let us check this one. Let me write this as I expect you to write an exam. So if you want to calculate this, what you need to do, you need to copy and paste G part and F part, but you need to write H of 0 for me. H of 0, it means that you go to the function H, I replace X with 0. So this becomes 2 times 0 minus 1. Then you need to go one more step to calculate this number. So this is the copy paste part, G and F. Instead of 2 times 0 minus 1, I simply write minus 1. Then I go to the function f and calculate this one. So what I need to do, I need to replace x with minus 1. So I will copy and paste the g part. I apply f of minus 1. So it becomes 2 plus minus 1. Then it becomes g of minus 1. And then g of minus 1, I go to my function g, I replace x with minus 1. So you are completely right. The answer is minus 4. And then you see that these two numbers are not equal.
2 plus minus 1 is 1, not minus 1.
Oh, thank you, thank you. So, oops, I am in a... So this is not a good example because this gives me the same answer back, yes. No, that was correct. That was correct. That was... You are right. That is correct, but I need to write that is positive 1. Thank you for correcting me. Yeah, that is a coincidence, of course. Then g of 1 becomes again 2. So I think, Rocco, you did the same mistake as I did here, yes? G of 1 is again
I did the
1
same
minus...
mistake, actually.
Pardon?
I did the same mistake as you both.
Yeah, so why?
yeah.
I don't know why we did all the same mistake. So anyway, it becomes minus 1 minus 3. So I am very unlucky person, by the way, because most of the time these numbers doesn't happen to match. But if I randomly give you an example, they match here. Yes, do you remember something like this yesterday? Okay, anyway, but this is a coincidence that these numbers are the same. In principle, the numbers could be different, but that's a coincidence here. Okay, let us do this function. So what do you think about this? F of h of f of 2. So what is the answer, anyone?
Well, I'm a bit scared because I got the last one wrong, but I got it to 9.
9. Okay, don't worry about that because I also got it wrong.
Me too.
So you are
Thank
saying
you.
9. Okay, let us calculate this. How should I calculate? I copy and paste the first and the second one, f and h, because I know that I have to do this one first. But what is f of 2? It means that I need to replace x with 2. So this becomes 2 plus 2. But nobody writes 2 plus 2 because there is a better name, and that is 4. Now I concentrate on calculating h of 4. So I replace the input for x with 4. So what happens? This becomes f of 2 times 4 minus 1, which is f of 7. And what is f of 7? Is 2 plus 7. And that is exactly 9. Now this time I think it's correct. Everybody agrees?
Yes.
Yeah.
Yes.
Yeah. So that is the number 9 that you get from here. So you see that you can combine these functions one after the other. Okay, there are some problems in the book. Let us do some of them together. Okay. Yeah, there is a nice problem. It is level 3 problem, but I don't think it is hard at all for you now. So let me mention it. Problem 4310. Matematik Origo. Also, Matematik should be like this. Origo 1C, and the page is 164. So the problem is this. Two functions are given to you. A function f of x is given to be 4x minus 1, 4x minus 2, sorry, and g of x is given to be x minus 1. The question is a good question. The question is that determine x such that f of g of x becomes equal to 42. So do you want to give this a try yourself first? This is a level 3 problem according to the book. Yeah, I mean the highest level.
Can
But
you
I
give
think
us a
it's
moment for this question?
yes. Yeah, I will pause the video here.
Thank you.
Oh, well. Okay, so my goal is I know that f of g of x is supposed to be 42. Okay, so I do this. So instead of going horizontally, let me go vertically. It might be it's easier. So I will copy f, but instead of g of x, I look at my function. X is the input. What is the output for g of x? It becomes x minus 1. So instead of g of x, I can put x minus 1. And then still it is supposed to be 42. Now to the next line. You need to read the function in this way. The role of this function, the action of this function is this. It takes an input x from you, it multiplies that input by 4 and subtract 2 from it. So it will always do the same thing. This is the only thing that this function knows. So now you need to understand that x minus 1 is playing the role of the input for the function. So the function will take that input, multiplies it by 4, and subtract 2 from it. So what you see that I have written here is something equal to this one. And then on the right hand side, I put equality 42. And then you can completely forget about the functions, just concentrate on this one, which is a Grundschoolen problem. You're supposed to find x, yes? You know what to do. That's an equation. I just multiply 4 there. It becomes this. On the right hand side, I have 42. So I have 4x minus 6 is equal to 42. I move 6 to the right hand side, it becomes 42 plus 6. 4x is equal to 48. And I want to make x alone. So I divide by 4. It becomes, as you said, 12. So this is a very simple, nice question. Okay, I think we have 9 minutes. So let us do the other problem. So at least we solved 2 of them. So another problem that I want to talk about is the same, on the same page, the next problem. So 443.11.
So if you solve these problems, does that mean they will not be on the test, or?
No, but I can find some way out of it. Okay, don't worry. If you
Okay.
understand them, that's okay. Yeah, I will give you the same questions. But of course, if I change this number from 2 to 3 and this number from 1 to 5, does it change the problem dramatically, do you think?
I mean, the
No.
method would be the same.
Pardon?
So the method would be the same, but you'd get a different answer.
Yeah, yes. So that's what I mean. You don't need to
Okay.
memorize questions, but you need to understand. And if you understand that, that's quite okay.
Babak, I have a question.
Yes?
I have done this example and I got 12, but on other way of solving it.
No, but that is important to talk me about your way, because it might be wrong and coincidentally give the right answer. Just let me know about your answer, your solution.
Yeah,
I also used a different solution.
I took -2 to their left side, so it'd be 44.
Yes.
And then I divided by 4, and then +1.
No, I would say that you need to write it in this way. So what you are saying, one way is also possible. So what you are saying, that why did you add 2 to 42?
To solve the equation.
No,
to get x.
another way, if I want to do it something similar to your way, which I don't want you to do it, it's very important to start from the inner function, not from the other function, okay? But if you insist, because in principle, G acts first and F comes after that. But you can say to yourself that, who cares? F is acting on G of X. So what is the role of f? F multiplies by 4 and subtract 2 from it. So if that is the case, so f will multiply what is its input and subtract 2 from it and equate it with 42. If you write this, that's also correct. So first of all, I want you to understand this is the correct way of writing, translating this. Because the function f, when the function is acting on x, it will multiply the x by 4 and subtract 2 on it. X is just the name of my input. But if I ask you what is the input of function f, you say that g of x is the input of my function f. So the function f will multiply it by 4 and subtract 2 from it, and the answer is 42. And then what you can do, you can add 2 to both sides, it becomes 44, and then you divide by 4, you get g of x is 11. But then if I ask you, this is g of x, not x. So you realize that g of x is also given to be x minus 1. X minus 1 is equal to 11, because instead of g of x, I can write x minus 1. If you write this, this is also 100% correct. But I don't want you to do it in this way, because I am just telling you that in the future, you might be in a little bit trouble if you want to do it in this way. But that is completely okay. There is nothing wrong with it. But you need to write, not guess. You need to write all these processes, okay, so that you can reach to this answer.
That is the same method that I used.
Yeah, that is quite valid. If you write something like this, I cannot deduct any points because that's completely right. Even though it's always better to understand. So it's always better to do these functions from the inner function to the outer function. This, if you get used to this way of thinking, it would be useful not just only for functions, for the concepts that are coming after the functions. Okay, so this is why I'm saying that both of them at this level is completely correct. But you have to write this, not guessing. So if you want to get the full points in the exam from this method, you have to write all these steps and then conclude that x is equal to 12. Is that okay?
Yes.
Okay. So let me write this as a remark here. So something, this method is more preferable. Okay, but both of them are actually correct. Because here, yeah, everything is correct. I couldn't say that this is wrong. I agree that both of them are correct, but I myself prefer to do this from the inner function to the outer function, yes? Okay, so there is no time for solving the next problem. I want you to think about that problem yourself, the next problem. I will start solving that next time. And then we will continue, because this is the hard part. And then there is one thing called exponential function that is also very good to know and solve some problems related to exponential functions. Okay, so let me stop this recording here.